BitShelf is a simple master detail app for PlayStation game collectors. The basic functionality of the app is a list of games are grabbed from a public API and displayed to the user, and the user can then click on a game to view further details. The user can then choose to add this game to a favorites list, called a shelf. The user can also search for games. This relies on a public API call that returns the result of the user query. Users can add search games to their favorites as well. So far, the main features of this app are its reliance on the MVVM architecture, its API caller, and its file management capabilities. To handle the API call, the app uses an asynchronous OK HTTP call with Kotlin coroutines and passes the data received from this call to its various live data objects. These objects are then transformed and mapped to live data objects in the browse view model, where observers of the live data objects watch for changes in the browse activity, which is the main activity. To manage favorites, the app employs internal files to which lists of game data objects are written. These files are stored in the files dir directory and are accessible by all activities, meaning data saved to a file in one activity can be accessed by another activity by simply reading the file. These files are not destroyed until the app is uninstalled, meaning the data written to them is persisted. Right now, the app uses multiple activities to display different screens to the user. While this works, it does not work well with a bottom navigation bar implementation, particularly when the user is rapidly changing between activities. It ends up being slow and may strain the hardware because of the constant creation and destruction of the activities. It also leads to unexpected fatal exceptions due to the volatility of the activity life cycles. The app follows a model view model, or MVVM architecture. This means the app's business logic, any logic not directly involved in presenting something to the user, is separated from the presentation logic, which is, in turn, logic that is involved in presenting something to the user. Successfully implementing this architecture has involved heavy use of live data and observers, because the MVVM architecture forbids a model from having direct reference to a view model, or a view model having direct reference to a view.